Hey guys, this is Arjun from OE Analytics. We're going to take a few minutes for everyone to join, and then we'll be kicking off the session. So please be patient and let's take a few minutes so that everyone will make sure everyone gets on. Hey everyone, this is Arjun again from OE Analytics. We have that's almost 9 minutes, I think. We have almost everyone. People are still joining in. People are coming in. But to give a quick introduction, I hope everyone can hear. Okay. My name is Arjun, and originally from Trivandrum, on the company based in the automotive industry in Detroit. So we wanted to give a brief idea and understanding of the topic of data analytics in general, and to also give a brief understanding of what OV Analytics is. We are a startup, tech startup uh, that is in and around the data analytics space. We are pursuing this industry to be a solution provider for corporates, and also at the same time work with students in order to train and educate and create the next generation of quality data analysts. There's a very big shortage of good data analysts in the market in general, as this is a very big booming industry, and we want to make sure we address the problem of the talent pipeline, and also be a solution provider for corporates as well. So it's an uh, end-to-end cycle, or it's an end-to-end service provider. So without taking too much, let me introduce to the other half of OE Analytics, Sailor, and I'll hand it over to him. He'll be doing the majority of the course. He'll be introducing the topic to you. So Sailor, if you can hear properly, you can go ahead. And you can also share the screen.
Yeah, sure thing. Thanks, Arjun, for the introduction. Okay, great. Rather than giving myself an introduction here, I'll just go ahead and start the presentation. Okay, is everyone able to see my screen?
Yep, you're good.
Okay, perfect. All right. Well, thanks again, everyone, for joining. I hope your weekend went well, and I appreciate everyone showing up and having the Sunday evening with me. So as the title slide suggests, this will be an introduction to data analytics and our data analytics course at OVE. So as a walkthrough of how this session will go, we'll begin with an introduction. Next, I'll walk through some applications where we see data analytics play out in real life. And finally, we'll end with a live example in which all of us will walk through a task common to a data analytics ask. So as promised, we'll begin with an introduction. So I guess it makes sense to start off with who I am. My name is Sela. I'm based in the US. Specifically, I'm based in Minneapolis, Minnesota. I'm currently working in the capacity of a data analyst in San Francisco. And just here, I've listed out a few of the institutions and companies that I've been a part of in the past. Okay. Next, we'll work through some webinar housekeeping notes. First and foremost, this session will be recorded. So if you miss something or if you would like to see something again, you will be able to do so. Second, please use the chat to ask questions. Both Arjun and I will be monitoring the chat throughout the session, so I will take pause and answer them as they go. That being said, if we do miss a question or if you have more that are outstanding, there will be a Q&A session at the end, so please stick around for that. All right, so now that we've gotten that out of the way, let's talk about what data analytics is. And I always pose this question at the beginning of these webinars because it helps inform the entire presentation. And basically the answer boils down to 3 points. Data analytics is the process of extracting data or pulling data together and cleaning it. The second step is once you have that data, you perform some sort of computation or apply some kind of algorithm to that data. In the third step, you take the result of that computation and you derive some sort of insights or conclusions based off of your computations. And this is a concept, this structure, this flow is something that we're going to revisit time and time again in this webinar. So it's worth saying once more. So data analytics is basically the process of extracting data, performing a computation, and deriving some insights. All right. So now that we know a little bit about what data analytics is, at least on a high level, now let's talk about where do we see it play out on a day-to-day basis. And the answer to that question is analytics is everywhere. Quite literally, it's data is recorded with every step you take. I don't know about what phones you all have, but my phone records every step that I take. And not only that, it records the number of calories that I burn, the number of flights of stairs that I take, and the locations that I go to. So quite literally, data is recorded at every step. Every time you make an online purchase, every time you visit your crush's social media page, all that data is recorded, stored, and it's just waiting to be analyzed. There are applications in business, healthcare, sports, government, social media, and I've listed out a few of the examples here. You probably recognize some, if not all of these logos, but if not, I'll actually just go through and quickly walk through some of these applications and how data analytics plays out within them. So here in this top left, we have Instagram. Most of you are probably familiar, but if not, it is a photo sharing application. And Instagram is really good at creating personalized media feeds based on the accounts you follow, posts you like, and content that you interact with. So they use that data as fodder for their algorithms that also help them create specific ad targeting. Additionally, they'll specifically create the content that they show you on your phone as a response to the posts that you like and that you follow. Next, let's move on to Amazon and Flipkart. These two examples here at the bottom. These two applications, if you're not familiar, you can go to these sites and buy pretty much anything under the sun. Anything that you need, Amazon and Flipkart can procure that and deliver those things to you. These two are very good at creating product recommendations based off of your viewing history, based off of products that you've purchased in the past. They're also good at analyzing trends in history. So come holiday season, these companies know that people are more willing to or more apt to buy certain products, so they push those things to the front of their websites during those times. Another thing that people don't really think about is delivery data. So they also track how effective they are and how quick they are at delivering some of these items. And after analyzing what they've done in the past, they are very good at optimizing those routes, saving time, saving costs across the board. All right, next, let's talk about Netflix. I'm more of a Hulu person myself, but I do have a Netflix account. If you're not familiar, this is a movie and TV streaming site. And again, similar to Flipkart and Amazon, they're very good at recommending things. So based on your viewing history, Netflix, Hulu, or Disney Plus, they will suggest other similar shows or other similar movies that you will probably enjoy, as well as a percentage of saying there's a 90% chance that you might enjoy this based off of our user base. They also do a lot of content analysis. So they look at across the board, what kind of content do people like? Which shows are doing well? Which shows should they renew contracts with? And then if someone approaches them with a new idea, they can actually take a piece of content and evaluate whether or not they think it is good based off of their data. Okay, next let's move on to this logo here. This is Manchester United, a football club, but this idea really expands to any sports team. I'm particularly not a big fan of Manchester United, but I know Arjun is. But like any good sports team, they have a big analytics unit. And this analytics unit, they help decide which players to buy. Based off of match history, they look at which tactics to implement and when. They are able to calculate win-loss percentages based off of game state data. They can help make decisions when to choose or switch to an ideal formation based off of the opposition or based off of the game state. And finally, they can help evaluate player performance based off of their historical performance in relation to what they're doing current day. All right, and the final examples that I'll run through right now are Mayo Clinic and the National Health Mission. So these are both large healthcare institutions that have collected a large amount of data. And this to me is particularly exciting because these two organizations are currently analyzing patterns in historical data. And in addition to that, they are lowering the bar to access your own healthcare information. So when it comes to healthcare and healthcare experiments, true experiments can be very difficult to conduct properly. They're very expensive and they require a lot of time. They also require people to volunteer and be a part of an experiment. Each participant has to cooperate fully, and they have to be tracked over time. Now, what is being done currently is these institutions are doing what are called retroactive experiments. And these retroactive experiments help bridge that gap of cost and time. They allow analysts to conduct simulated experiments to look at certain populations and see how they have responded to certain stimuli, whether these are drugs or different trials, and then they see the health outcomes as they go. Rather than having to wait the 30 years, you can look at 30 years of data and move from there. All right, so that is a little bit of an overview, introduction to data analytics. So let's go ahead and move into some applications. But before we do so, I want to pause and ask if anyone has any questions. If you have any, please drop them in the chat. All right, cool. Looks like we've got nothing, so let's continue on into some applications. Okay. So researchers at the University of Ulsan College of Medicine in Seoul, South Korea, created a study in which, I'll just read the intro to you. Studies have shown that mammographic screening significantly reduces breast cancer mortality. Despite such efforts, breast cancer is still the most common cancer and the leading cause of cancer-related deaths in women across the world. In fact, in mammography, 10 to 30% of breast cancers can be missed. So even if you have trained doctors looking at your MRI, it's still possible that they may miss the cancer that is there in the tissue. So with this in mind, these researchers set out to create an algorithm that could look at these X-rays and see if they could create something that could predict or identify breast cancer at the same rate of, or hopefully better than, doctors. And that's exactly what happened. The AI algorithm developed with large-scale mammography data showed better diagnostic performance in breast cancer detection when compared to radiologists. And if you want to see the details of this experiment, if you want to see how it was done, you can actually click on this link here that I've attached and look at it yourself. Okay. In this image, we see, in fact, this image harkens back to one of the slides that I had in the beginning, where I talked about what data analytics basically boils down to, right? It's the idea of taking data, performing a computation, and deriving an insight from that. And this breaks that down exactly. So in this case, the data is mammographic screening. It's these X-rays, these X-ray images. So they fed this data into this model, and this model performed a computation after looking at thousands and thousands of examples. And at the end, it created an output. It was able to identify breast cancer at a higher rate than the doctors were able to do. All right, next let's move on to a more tangible day-to-day example. This is Zomato, as many of you may be familiar with. I live in the States, so I personally use Yelp quite a bit, but the idea is effectively the same. On these sites, users log in and leave reviews of restaurants, they leave reviews of food, and this in itself is very valuable data. In fact, Zomato, if you click on this link below, it'll take you directly to their personalized food recommender system. So this system essentially identifies relevant information pertaining to each item separately in the reviews. It uses a sentiment check on these pieces of text and accordingly suggests an appropriate restaurant for the particular item depending on user item and item-to-item similarity. So if I were to go to these two restaurants, for example, and I were to go to a completely different region, Zomato would be able to ingest my eating pattern, no pun intended, and they would see what I like to eat, see the places that I've liked to visit, and from there recommend a restaurant in a completely different area without my having been there before. And having used apps like these often, I really appreciate this feature. Okay. So next, let's move into understanding in more depth what data is. And a lot of times people refer to the 5 V's of big data. So we'll go ahead and walk through these. So the first V is volume. And for this point, we ask the question, how big is the data? Are we talking about 100 columns, 100 rows? Or are we talking about thousands of columns, millions of rows even? These factors determine how we need to store, access, process, and use this data. The second V is velocity. So how quickly is this data being produced or recorded? Is this like US Census data, which is collected every 10 years? Is data coming in batches every month from reports? Is it coming in every day? Or is this data happening in real time as soon as the events occur, like streaming data? The third V is variety. So what form does this data take? Is it structured or is it unstructured? In structured data, we think of rows and columns, typical of maybe an Excel sheet, whereas unstructured data is more like the first example that we saw with the MRI scans. So those are images. Video can be taken as data. Text can be taken as data. Tweets can be taken as data. The fourth V is veracity or validity. Is this data clean? Is it accurate? Is it robust? And this point is central to the entire practice. If you have unreliable, inaccurate, or overly incomplete data, there's not much that you can do with it. You can't draw strong conclusions or perform accurate analyses. And this fourth V relates directly to the fifth V, which is value, which begs the question, what can this data be used for? What insights can we glean? Because if you don't have strong data to work with in the beginning, you can't say anything, you can't make any conclusions in the end, and that has a direct relationship with value. All right, so that's what data looks like. It's growing, it's massive, but most people don't have the tools that are actually publicly available to work with this data. And that to us is what is exciting. That's what makes this course exciting. There's a ton of room for innovation, insight, optimization, growth, and advancement within the field of data analytics. Next, let's talk about what a data analyst actually does on a day-to-day basis. So essentially, we work in the past, the present, and the future. So in the past, we look at historical data to uncover trends, detect anomalies, and study the effects of major events or campaigns, and conduct historical experiments. In the present, we assess where things currently stand in relation to events that have happened in the past. We can look at this time a year ago. We can look at this time compared to 2 years ago, and so on and so forth. The third is the future. So we create models to predict the future for the purpose of setting goals, strategizing, informing policy. And if you think back to the examples that I've shared thus far, you can see how data analysts do deal with the past, the present, and the future. And just on the bottom here, I've listed out a few of the tools that are typically used among data analysts. You're probably familiar with some of these, but if not, this is Excel at the bottom here. You can view spreadsheets. I'm sure most of us are experienced or have seen Excel. R, Python, and SAS. These are also very powerful data analytics tools where once you've pulled the data, you can start to work with it, you can manipulate it, clean it up, and create your models using this software. And then this is SQL here in blue. Typically, SQL is used to pull data from databases. Usually data is stored in some warehouse, and then you create queries in SQL to pull that data. All right. And with the last piece, we're going to go into a live example in which we will tackle a problem as if we were data analysts ourselves. But before I go on, I want to ask again if there are any questions.
participants, if you have any questions, you can just type it in the chat box. Mr. Shaila will definitely answer you. If you have any questions, please do type it in the chat box, or you can unmute and you can ask the questions.
Also, there's one thing to add. If you can go to the slide before for a second. Yeah. So if anyone, just to make it a little more interesting, if anyone has any previous experience in R, Python, SQL, I'll add Tableau in there as well, or any analytics or business analytics tools that you have used in Excel. Why don't you put that in the chat box? Just put what the background was, just to see where we stand as far as what we know is concerned. So just to make it a little interesting, if you have any background on any of these tools or analytics in itself, please go ahead and type those in as well. But like I was saying, anytime if you have questions, just put that in, and we can. But at the end, if it is through it, we can answer it.
All right. Yeah. Thank you. Those are good tips. Yeah, definitely. If you have any experience with any of these software, other data analytics software, please drop those below. I'd love to see that. Okay. So if there aren't any questions, let's go ahead and dive right into our live example. So this is the question that is being posed to us. Suppose that we have been hired as data analysts at an Iowa-based real estate company. Our task that we've been given is to create a model that will be able to predict a property sales price, or rather, it will be able to predict property sales prices given information about these properties. In order to accomplish this task, we've been given information regarding property sales that occurred in Ames, Iowa from 2006 to 2010. Now, the fact that these properties were sold in this time period is not important. What is important is that we've been tasked with creating some sort of model that will be able to predict these sales prices. So I'm going to go ahead and open a script that I've already written for this. Can everyone see the screen? Is this text readable, or should I zoom in a little bit? All right. I'm just going to assume that everyone can see, and I'll proceed from here. Okay. So first, I'll begin with loading in some packages that will be useful in conducting this analysis. And before I go any further, I wanted to note that I have two references for this, in creating this example for our webinar. So if you would like, you can definitely check these out. I will make sure that this file will be accessible to you all. Okay. So again, we've been hired as data analysts for this Iowa-based real estate company, and we are going to create a model that will predict property sales price. So let's go ahead and take a look at the data that we'll be looking at. As a very first step, it's always smart, and in fact, it's imperative to look at your data, explore it, and see what's going on. Let's go ahead and do that. Okay. So as you can see, our data set has 2,930 rows and 82 columns. I'll be referring to these 82 columns as variables, and then these 2,930 examples as the properties. And actually, I think it's more helpful if we look at the data as so. So each row here represents a specific property. Each one has an ID, and then you have all of the...
Say a quick question. Are you sharing our screen?
I am.
Oh, it's actually in the webinar, so
Oh, you can't even see the R that I'm doing. Okay.
no.
Okay. Let me try. Okay. I'll start that portion over again.
There we go. Yeah.
Okay. All right. I'll start this again. My apologies. Okay. So as I said before, this is the script that I've written, and yeah. Let me just sure. Okay. So I began by attaching, or rather loading in these packages that will be necessary for conducting this analysis. And you haven't missed much. All I've done is shown you this much. And this is the data that we're working with. So every property here is listed out. Each property corresponds to a single row here. So if we take the first property, for example, it has a lot frontage of 141 square feet. The entire area is 31,000 square feet. Some other details about this. It has one story, so one floor. It was built in the year 1960. And if we go to the very end, we can see that this property sold for $215,000 US. And so this entire file has 2,930 examples of such properties and all of the details related to them. Okay, nice. So now that we have a sense of what the data looks like, let's dive into the thing that we're actually trying to predict, which again is sales price. So in order to build an accurate and reliable model, we first need to understand what it is we're predicting. So I wrote a little chunk of code that breaks down what sales price looks like. So this is a frequency histogram in which each single point is a property, and I plotted it over sales price. So as you can see, most of the houses fell into this range here, and there was a tail towards the end. And logically, this makes sense because most people can't afford houses in the upper range, and it makes sense that most houses fall into this area here. So if we want to take a look at what this graph represents numerically, we can do that using a call to summary. So we can see that the median price of a house was $160,000, and the mean was a little bit more at $180,000, which again makes sense because we have this upper tail, and because of that, the mean is skewed higher than the median. So these things check out. Okay, so now that we understand the thing that we are predicting, let's take a look at the other variables further. And in particular, let's see which variables have some sort of relationship with sales price. We could expect that these variables would have some sort of influence or would be valuable in including in some kind of model. And one way to do that is through correlation. And so correlation, if you're unfamiliar, it is a statistic between -1 and 1 that shows a relationship between two variables. So we can actually plot that here. And this is a little bit difficult to see. Okay, great. So we pulled out the variables that are the most correlated with sales price. And the way that you can read this is you take one variable on this side and you look at the variable on the other side and see how it's correlated. So this is represented in both numbers and in circles. So the darker and larger the circle, the more correlated. Obviously, the higher the number, the more correlated as well. So as we can see, overall quality and sales price. The overall quality is the most highly correlated value with sales price. And then dropping below that, we have living area, garage, the number of cars in the garage area, total basement square footage, so on and so forth. And just to have a sort of common sense check to make sure that we're doing this correctly, if we look at the garage area as compared to the number of cars in the garage, we see that there is a high correlation, which we might expect because the larger the garage, the more cars you could probably fit in there. So this makes sense. And it also makes sense that this would inform sales price as well. All right, so let's close that. Go back to our example. Right. So as shown by this plot here, overall quality was the highest correlated metric that we have with sales price. So let's go ahead and take a look at it. So overall quality, just to give you a little bit of background on what the metric is, it is an evaluation of how well preserved or how good a property is on a scale of 1 to 10. And you may be familiar with some of these plots. These are box plots, which contain the lower quartile, third quartile, as well as outliers. And the graph above shows actually the exact same information as the one below. The difference being that this is a density plot, this is a box and whiskers plot. The above just looks nicer, and there's actually some utility in that. Being able to show pretty plots and the ability to show good plots is important to stakeholders, to clients. It helps illustrate your point more cleanly. So as we saw above with the correlation plot, this holds true. So as overall quality increases, so too does sales. So too does sales price. And this is in line with what we were expecting to see. All right. So while tackling a problem like this, it's imperative for data analysts to be able to think outside the box. So you have your set of data, and what I've done here is I've thought of, okay, I noticed that there is no way, rather there is no metric that contains the entire square footage of a property, and there's also not a metric that includes the number of floors. However, there is data about square footage on specific floors, and there are counts of floors individually. So I went ahead and created two metrics, two variables rather, one for total square footage and one for the number of floors. Let's go ahead and run this code to see what that looks like. So I plotted total square footage against sales price, and I've colored the specific data points with the number of floors. And this meets my common sense practices as well, because as total square footage increases, so too does sales price, which I would expect to see. Additionally, there's a cluster of red here, denoting that most of the properties and towards the lower end had 1 floor, whereas those towards the higher end had 2 and 3 floors. Next, let's take a look at a few variables of different types. We've already seen a few important continuous or numeric variables. So now let's take a look at some discrete or categorical ones. Okay, so now we're looking at neighborhoods in comparison to sales price. I won't go into too much detail about how I ascertained that this variable was important, but if you take the course, I will definitely share. Basically, this breaks down the different neighborhoods in this data set and how many properties fell into each neighborhood, and additionally, what the sales price was for each one. And this red here denotes the median value. Okay, so now that we've done some exploratory analysis and we've looked at a few of the variables as well as the sales price itself, the next step is to do the data cleaning. So as I mentioned before, this is the most important task, and it is oftentimes the most time consuming. And this data set contains a decent amount of strangely categorized or missing, or what I like to call almost helpful data. So our job next is to clean it up. But to illustrate how much is missing, I've included this little visual here. So pool quality, for example, is missing almost every single one of its values. So this is probably a metric that will end up dropping. But from here, we have miscellaneous features, alleys, and fences. All of these variables are missing data. Cool. So next, I've included this large chunk of code in which I go through and clean everything up. But rather than walking through that, I think it makes sense to just show one example. As you mentioned, the pool metrics, or the pool variables rather, are missing quite a lot of data. And as I looked through it, it made sense because these properties are all in Ames, Iowa. Iowa is a very cold place in the United States, so it makes sense that a lot of the pool data is missing. So I just went ahead and accounted for that in this code here. But for the sake of time, let's go ahead and just run through all of it at once. Okay, so now that we've skipped through, or rather we've gone through the data cleaning process, we can start building out our model. And this to me is always the most exciting portion. It's where I get to be the most creative. It's where I get to do the most experimentation. And this is the most enjoyable part. So we'll begin with the most straightforward and basic approach. Again, our task was to build something that could predict sales price. And so I'll begin with something that is very basic, and that will be a linear regression model. So if you're not familiar with what this is, I can show you this plot here. Okay.
Say, let's just interject. We got 10 minutes, so can skim through a little bit of the code, and you can use it.
Okay, sure thing. I appreciate the update. I'll go through this pretty quickly then. Given a plot like this, the goal of linear regression is to fit a line that minimizes the errors between each data point. And the error in this case is the distance between a single dot and the line. So again, the goal is to minimize the errors across all of these dots. All right. Switching back to the code then. This model, this chunk of code essentially does that. So my first step is to shuffle the data so there's no bias. I'll then grab only the numeric data just for simplicity. We're doing this in actual practice. We begin with a model like this and then move on to expanding over all variables. The next step is to split the data set into both training and test sets so that we're able to train the model and evaluate it. Then we'll remove the sales price so that it won't be one of the variables we include when predicting sales price. Train the model. Finally, we'll get our result. The result is that we created a model that had about $40,000 in error. And this is not great, obviously. But we've completed the task at this point. We've built a model that could ingest new data, given all of those information and data points that we saw, and predict something. So to put this in context, this 40,000, remember the median price was 160,000, median 180. So 40,000, not that great, but a decent first shot. From here, there are a number of ways we could improve this model or implement a new one to include more of those data points. Okay. So I know we don't have too much time left, so let's go ahead and continue. We've gone through the introduction. We talked about a few applications in real life, and we walked through a live example. So this is the course that we will be building that you will have the opportunity to take. We'll walk through SQL basics, R basics, the fundamentals of statistics, data wrangling, cleaning, processing, and visualization, and just overall good tools for a data analyst. And in addition to that, we'll be talking about agile program management throughout the course. All right. Thank you all so much for I really appreciate it. If you have questions, please ask those in the chat now. This is our social media, so you will be able to reach us through that as well.
Yep, and just to add, I think I can switch my video. Now that we have come to almost to the conclusion, but anyone who has any questions, please go ahead and put it in the chat. So just to add, at the beginning we were trying to mention that, or we started out with that we're trying to build a course, and our objective is to make sure to build a course that will prepare anyone who go through that process will come out at the end as an employable data analyst, and that is the section that we are putting our focus on, because by the end of it we want to make sure we either line you up with a job or, and more importantly, make sure you are qualified to go into the field and make you ready to go into any organization, and will be able to provide value there. Essentially, we want to try to aim early next year. We have your email list, so once we have the course completely figured out and launch date figured out, we'll reach out to you. But then again, we have to make sure that we are okay with the code guidelines, so we'll have to wait a little bit on then we can actually start. But thank you all for joining, but let's use this time for questions, and Gautam, if you have anything you can add.
So thank you, Shaila and Arjun, for your valuable time spent with us. It was so great of you to have shared quite a few insights on data analytics. And participants, do you have any questions to Shaila or Mr. Arjun? Any questions? You are most welcome to unmute and ask, or you can just type it in the chat box if you want. Gauri Shri, Monisha, Sham Kumar, Fida, Ashtami, Ashna, Amal, any questions to Shaila and Arjun? So we'll just take up questions like quickly. If you have any questions, you can unmute or you can just type it in the chat box. They are for you. They have spent their valuable time to enlighten us on this topic, data analytics. Any questions, guys? Okay. So on behalf of the participants,
So one other thing.
please.
Gautam, we'll leave on the chat. We'll leave our email ID. If you guys have any questions, please feel free to reach out to us at any time regarding course or analytics in general. We should be able to find some time. Either to, reply for sure, but if you want to set up a call or try to talk a little bit more, we should be able to find time. So just to, I'll put that in the chat, by the way.
Okay, sure. So they have given you the email ID and the websites. So if any questions you have, you can just contact them through the email, okay, or the relevant websites, and you can just get in touch with Mr. Shaila or Mr. Arjun. So that brings up to the end of this session. So thanks a lot, participants, and thanks a lot, Mr. Shaila and Mr. Arjun, for your valuable time spent here to enlighten us on this data analytics. So good luck to everyone and hope to meet you soon in another program. Thanks a lot. On behalf of Jay's Academy, I thank our resource person as well as the participants for making this program a grand success. So thank you, Mr. Shaila, and thank you, Mr. Arjun. Thank you all for making this program a grand success. Thank you once again.
Thank you guys. Thank you for joining in. It's OV Analytics at I think I made a mistake on the spelling, but OV Analytics at gmail.com or through social media. That should be fine.
Yeah, sure.
Thank you guys again.
Thank you, Shaila, and thank you, Arjun. Thank you very much. Thank you, participants. So Mr. Arjun has given the email ID. So it's in the chat box. You can just note down the email ID and you can just contact him for any further queries. Participants, are you able to see Arjun's email ID there? For any further queries, you can just get in touch with him.
Yeah. Also, additionally, if you guys are part of this academy, then please touch base with Jair or girls or even actually. So that should be fine too. They all should be able to reach out to me. No worries there too. So anything, any questions or queries or any issues, just please reach out to us. No problem. And thank you once again.
Yeah, thank you.
Thank you, Gautam.
Thank you, Arjun. Thanks a lot. Thanks for the valuable time and thank you, participants. Stay home, stay safe. Thank you.
Bye-bye.
Thank you, Arjun.